Good evening. Today we are going to see the questions which were asked in May 2018 SPPU. So you can go through this playlist. So this is for M3 Unit 1. And then we have fluid mechanics also over here. And then we have mechanics of material, where we have strength of materials. So now we have first, that is, draw shear force bending moment diagram for the overhanging beam carrying as shown in figure, and also locate the point of contra flexure. Now this is most important. Contra means opposite. So opposite, and flexure means moment. Opposite and flexure means moment. Means we have to find the moment where our sign of bending moment changes. So now we have to first find always reaction when we will talk about shear force and bending moment. So we will take moment about A0. So we have UDL throughout. So 5 plus 2, 7 meter. So we have, this will be 7 meter UDL, and it will act at center. So I can write it as 20 into 7 and 3.5 meter from A or 3.5 meter from C. So we have 20 into 7 into 3.5. Then we have 10 kilonewton, that is at point C. So we have plus 10 into 7 minus VB into 5, and that is equal to 0. And from this we will get value of VB, that is equal to, so 20 into 7 into 3.5 plus 70 divided by 5. So it is 112 kilonewton. So value of VB is 112 kilonewton. Then apply summation Fy equal to 0. So we have VA, then we have minus 20 into 7, that is acting downward, plus VB minus 10 equal to 0. And from this we will get VA equal to, so 20, 140 plus 10, 150 minus 112. And then we will get this, that is equal to 38 kilonewton. So we have VA 38 and VB 112. So VA 38 kilonewton and VB we have 112 kilonewtons. Now first we will go with shear force. So we have first left of A, we have 0. Then we have right of A. So we have right of A, that is equal to 38 kilonewton. I will plot it simultaneously. So we have this as 38 kilonewton. Then we have third, left of B. So left of B we have 38 minus 20 into 5, because 5 meter UDL is on left of B, and therefore we will get it as minus, so 62 kilonewton. So now you can see we have 62 as it is shown downward. So it indicates it is minus 62. Then we have fourth, right of B. Then we have right of B, that is equal to minus 62 plus 112. And then you can see this, so 112. And then we have this as 50 kilonewtons. Then you can see we have this as 50 kilonewtons. So as we have throughout UDL, so that is x to the power 0. So we have throughout x to the power 1. And then we have a left of C, because we have again 10 kilonewton load over there. So left of C, so we have 50 minus 20 into 2, that is 10 kilonewtons. And then we have 10 kilonewton. So you can see this 10 kilonewton, x to the power 1 again, because here we have x to the power 0. And right of C, we have 0. So right of C, 0. So we have 0. So likewise, we have shear force diagram for given UDL. Now we have to find point of 0 shear force. So let us, we will consider a portion, and that is at a distance x from here. So what we will get? So we will have this as 38 kilonewtons, and UDL we have 20 kilonewton per meter. So we have this as 20 kilonewton per meter. So this is x. So shear force equal to 0 equal to 38 minus 20 into x. And from this we will get x equal to 38 upon 20, and that is 1.9 meter from A. So shear force will be 0 at 1.9 meter from A. So we have this distance 1.9 meters. Now we will switch over to the bending moment. So we have this as SFD in kilonewton. So we have this will be SFD, and we have AD 1.9 meters. And this reaction we have 38 kilonewtons, and this is 112 kilonewtons. Now we will switch over to bending moment. So now we have first at A, we have 0. Then we will find at point D where we have bending moment 0. So we can write it at D where we have shear force 0. That is M max. Now we will find this. So we have to consider 1.9 meter. So I will take 1.9 meter only. This is most important. So 1.9 meters. Then we have this as 20 kilonewton per meter, and concentrated load 38 kilonewton. And then we have M max, that is equal to 38 into 1.9 minus 20 into 1.9 into 1.9 by 2. We are taking bending moment at this point, and calculating this value, we have 38 into 1.9 minus 20 into 1.9 square by 2. So we have this value equal to 36.1 kilonewton meters. So now we will plot this till point D. So we have this as 36.1 kilonewton meter. Then we have to find value at B. So at B. Now you have choice, you can come from left or you can come from right. If you will come from left, I will write from left. So we have that is equal to 38 into 5 minus 20 into 5 into 5 by 2. So we have 38 into 5 minus 20 into 5 square by 2, and we have this value. We have this value of bending moment as 50 kilonewton meter. So just check it. So 38. So we have 38 into 5 minus we have 10 into, so we have actually this value that is equal to 60, not 50. 20 twos are 40 and 10 twos are, so this value is 60. So we have equal to 60 kilonewton meter. Now you can find it from right also. If I will take a right side, so right side what we will get equal to. So this is actually value we will got it as minus 60. So 38 into 5 minus 250. So minus 60. From right side, you can see we have minus 20 into 2 into 1 minus 10 into 2. This side also we have minus 60. Clockwise right side, so minus. So you can see we have 20 into 2, that will be at center. This is 1 meter. And due to 10, we have 20. So likewise, we have this as 60 kilonewton meter. That is at B. So you can find from left or you can find from right. So likewise, we have this problem that where we have draw SFD and BMG. Now this question that was asked in May 2018 again, and we have to construct loading diagram. And then we have for the following, and also we are going to plot BMT. If not asked in examination, do not plot. But here we will find it. So now we have given this. So we will start with this shear force, sorry, loading diagram. Loading diagram. So now we have at A. So first at A. Now final shear force minus initial shear force. Final shear force minus initial shear force. Now we have final shear force 56 minus initially 0. So we have 56 kilonewton. So we will plot this. We have upward value reaction 56 kilonewton. Then we have, so this is at A. Then we have between A to C. Between A to C. So we have between A to C, W intensity of UDL, that is final shear force minus initial shear force upon span. Initial shear force upon span. Final shear force we have minus 16. Then initial shear force we have minus 56 and span we have 4. So we have 56, 6, 62, 72 upon 4. So this is minus 18 kilonewton per meter. Means we have UDL in downward direction 18 kilonewton per meter. Then we have to find actually point of zero shear force here. So that we will find later. So now we have third, we have vertical ordinate at B. So we have at B. Now final shear force we have. Now we are coming from this. We are at C. Then we will go in this way. So final we have 0. Initial is minus 16. So we have 0 minus of minus 16. And we have that is plus 16. Means we have upward. So we have this as loading diagram. Then we will find shear force equal to 0. And then I will directly write 56 minus 18 into x. So we have somewhere here. So we will assume this distance as x. So we have 56 minus 18 into x. And from this we will get 56 upon 18. So we have 56 upon 18, 3.11 meters. So we are equal to 3.11 meters. So we have this as 3.11 meter. And now we will switch over to bending moment diagram. So we have this as loading diagram and we have this as 3.11 meters. Now we will go bending moment. Bending moment. So we have at A, we have value 0. So at A equal to 0. Now we have to find at D where we have shear force 0. At D, shear force equal to 0. So we have M max. What is distance? 3.11. So now you can write 56 into 3.11 minus UDL we have 18 into 3.11 into 3.11 by 2. And from this we will get this value 56 into 3.11 minus 18 into 3.11 square by 2. So 3.11 square by 2. And we have this value 87.11 kilonewton meter. So we have 87.11 kilonewton meter. I will plot this first. So we have at D, that value is 87.11 kilonewton meter. Then we will find at C. Now you can go from left or you can go from right. So first from left we will get it as 56 into 4, because AC we have this distance as 4 meters and this distance we have 5 meters, into 4 minus 18 into 4 into 4 by 2. And we will have this value 56 into 4 minus, so 80 kilonewton meter. So that is 80 kilonewton meter at C. And if we will go from right side, so it is very simple. We have 16 into 5 anti-clockwise plus, so 80 kilonewton meter. If you have any this or this, and then we have 80 kilonewton meter. And then at B, obviously we have at B value is 0. Now polynomial function you can see loading x to the power 0, shear force x to the power 1, bending moment x to the power 2. Then C to B, we do not have any load, so shear force x to the power 0, bending moment x to the power 1. So likewise, we have to solve the problems which are from your question paper. So now we will stop here only. The remaining part we will see in the next lecture. So thank you.